Hi. When I bought two ESP32-S3 boards from an online store, I was surprised to discover that I couldn't even get my ESP-PROG to handle basic debugging. Have you run into this issue too? The good news is that the boards were still working and could still be flashed through UART0. Let's walk through how I solved it. Before we begin, make sure you have the required hardware ready. An ESP-PROG or ESP-PROG 2, together with an ESP32-S3 dev kit or module. You might be wondering, since the ESP32-S3 already has built-in USB JTAG, why don't we use it? That is a very fair question. The trade-off is that the built-in USB JTAG can be unstable, especially when it comes to ISR debugging or when the ESP32-S3 hits a hard fault. Now, let me show you how I wired everything up. I'm using a standard 2.54 mm JTAG socket. And this is one of those steps where it is absolutely worth slowing down and double-checking every connection carefully. For the ESP32-S3 dev kit, there is one small but important hardware modification you need to make before JTAG debugging will work properly. Solder the in-out jumpers so the board can take power directly from the VJTAG pin. There is one small detail that can easily be overlooked, but it's extremely important: the VJTAG power and ground wiring. Also, be sure to set JP2 on the ESP-PROG to 5 volts. That setting is essential for stable operation. And here comes a very important safety warning. If you are powering the ESP32-S3 board through the ESP-PROG VJTAG pin, never connect USB power at the same time. That can create a power conflict and may even damage the board. In summary, before you go any further, make sure only one power source is connected. Now it is time to install Espressif-IDE so we can begin debugging the board. Let's search for it on Google and download it. I'll use the online installer to make sure I get the latest version. Alright, the download is complete. Let's begin the installation. Before we move on, make sure you already have Git installed on your Windows machine. When you arrive at the prerequisite step, make sure all the requirements are satisfied. If anything is missing, just click Apply Fix and let the installer resolve it automatically. Since this is a fresh installation and my computer does not have ESP-IDF installed yet, I will choose the first option, which is to download the ESP-IDF package. Then click Next and select the version you want. Personally, I usually choose the latest version. Now, let's continue with the installation. At this stage, you can safely leave all the options at their default settings. The installation may take a while, so I'll speed up this part of the video to save you time. And there we go, the installation is now complete. Please don't be surprised if you see 2 command line windows appear. One of them will be a PowerShell window. To verify that the ESP-IDF SDK has been installed correctly, type idf.py-v. If everything is set up properly, it should display the version information without any errors. Now we are at a very important step. Connect the lower USB port of the ESP32-S3 board to your PC. Then press and hold the boot button. Tap the reset button and release the boot button. This will put the board into flashing mode. Now we are going to move on to a very important step, changing the board's eFuse settings to enable external JTAG. Open the ESP-IDF command prompt and run the command shown here to get the eFuse summary. Before that, check Device Manager and confirm the correct COM port for your board. Now, from the summary, look for the JTAG-related eFuse fields. If your board is brand new, these flags should normally all be false. Here, I'm going to set strap JTAG SEL to true. This means external JTAG can be enabled by pulling GPIO3 to ground during boot. After burning the eFuses, run the summary command again to verify that the changes have been applied correctly. Under normal conditions, this should work without any issues unless there's a problem with the UART connection. Now we are ready for the real debugging part. Open Espressif-IDE and create a Hello World project from the provided examples. Before you continue, make sure your project target is set correctly. For this example, it should be ESP32-S3. You can use a different ESP32 board if you like, but the selected target must match your actual hardware. Let's perform a compilation and build. Great! The compilation is done and it is built successfully. Next, go to Launch Configuration and set Flash over to JTAG. This is an important step before we start debugging. Also, before moving on, check the launch target settings carefully. Make sure the IDF target matches your board. And for my setup, the debugger is set to ESP-PROG. Now go ahead and connect the ESP-PROG to your computer. Remember, do not connect any USB cable to the ESP32-S3 board at this point, because it is already being powered through the external debugger. Then open Device Manager, because the next step is to configure the interface driver with Zadig. One more important reminder, before powering up the board, make sure GPIO3 is connected to ground. This ensures that JTAG is enabled during boot. At this point, you can search for Zadig on Google and download it. This is the tool recommended by Espressif for installing the correct interface driver. Next, open Zadig and enable List All Devices. You should see dual RS232HS interface 0 and interface 1 listed there. For this setup, we only need to replace the driver for interface 0. One important note, after this step, a computer restart is required. And if you later move the ESP-PROG to a different USB port, you may need to repeat the driver setup again. So far, everything is looking good. Under IDF target, you should now be able to see and select the COM port exposed by the debugger, which was not visible before. We have now reached the final stage. Go ahead and press the Run button to flash the code to the ESP32-S3. As you can see, the flashing process completed successfully. This also confirms that the wiring between the ESP-PROG and the ESP32-S3 is correct. If debugging does not work, or if the target cannot be scanned, check GPIO3 first. Make sure it is connected to ground. Then press the reset button to reboot the board. Now let's switch to debug mode and see what happens. What? Debugging is not working as expected. Something is clearly wrong. So let's go back and check the debug settings again. We found the issue. ARM semihosting must be turned off. Because the ESP32-S3 is not an ARM-based processor. Let's give it another try. It may take a little time for the board to enter debug mode. But now we are getting somewhere. The board has entered debug mode. But we still need to wait for the GDB server to become ready. Great! We are now in debug mode. You can see the small arrow pointing at main. That arrow shows the line currently being executed. Now let's set a breakpoint by double-clicking the desired line number in the left margin. Once it is set, you should see a dot appear. Thank you for taking the time to watch this video. I hope it helps you on your journey into ESP32 debugging.